Okay, math and engineering, I'm at home one more day watching my son who's sick, and hopefully I'll be back tomorrow. Should be back tomorrow. Anyway, you should get out your packet, make sure your name is there, and I'm going to go through what you should have done by now, what you need to finish today. Do not keep this, going. If you don't finish it today, take it home and finish it. Okay. So first, let's just talk about where we've been. So these pages right here, our previous pages. These pages have the observations that we wrote down. So these are previous pages. We had a lot of discussion and such before we had these packets on these. So where it says teacher checkpoint down here, I'm going to sign this off just if I see completion in like writing down your responses to these things. And then I'll check it off. So that's the first assignment in this section. There is an exceeding part, which I've covered over here, but there is an exceeding part that you could do. Many of us taped that over, but that's fine. Okay, and then what we just were doing was addition, subtraction, multiplication, division. This is the answer key for you to check your work, not copy your work. Check it and make corrections. But what I want to show you here, and I'm not going to have enough time for you to do this, you're going to come up here when you've checked your work and you're good to go. You're going to pick a challenge problem. So in this meeting section, you can see there's 4 challenge problems. 5 minus 2i and negative 2 plus I. This addition problem, that's 1 challenge problem. So there's 4 here, and every exceeding section has 2. The reason why there's multiple is not because I want you to do 6 problems. I actually only want you to do 1. Pick 1 in this category and do it in this section on your paper. The reason why there's multiple is I don't want you to pick the same one as your neighbor. Like, you shouldn't be doing the same problems. It should be your problem, not something that you're doing with someone else, something that you're doing alone, okay? To show me that you know how to do it, okay? You're more than welcome to ask as many questions as you want on all of these other questions and have people walk you through them, but on this problem and all of these other ones, you can see it here, that's your problem to do by yourself without help, okay? Now, the next thing that I want to let you know about these problems is that I paired them. So you can see where it says 5 minus 2i and negative 2 plus I, and down here it says 5 minus I and negative 2 plus I, but the difference is addition and subtraction. So when you pick one, you're picking a pair of problems. So if you pick that one, you're picking both of those. Those go together. And then on the multiplication division, the same thing holds true. So if you pick this one for the exceeding 5 minus 3i, negative 2 plus I, if you go over here for the exceeding, you'll see it's 5 minus 3i, negative 2 plus I. It's just division versus multiplication of the same problem. And so you're picking a pair there as well. You can pick from the meeting on addition, subtraction, and from the exceeding on multiplication, division, or vice versa. You can pick the exceeding on the addition, subtraction, and from the meeting on the multiplication and division. If you get them correct and you complete the assignment, that'd be meeting exceeding. If you do the challenge problems and nothing else, and you get them correct, like, you won't get a meeting or exceeding level grade, but you also won't get a 0. So if you know how to do it, like, at least do that one problem. At least finish that one problem for each section. But if you also do the entire assignment, but you don't do the challenge problems, the highest grade that I can give you is an approaching meeting. If you did like all the way down to all of these exceeding level questions, I can't give you above approaching meeting unless you do the challenge problems. Okay. All right. So that's previous. That was last time. That's what to wrap up. And then when you're ready, you can pause the video here if you're not ready. Pause it and just go do those things. But when you're ready, this is when I'll get to this sheet of paper. This actually is coming later. This we'll do tomorrow. So it's this sheet of paper that we need to do or start today. Okay? And so I'm going to walk you through it. Now, the first thing it says at the top, and again, if you're not ready for this, if you haven't done the other stuff, pause, come back to this. It says, use the unit circle to raise each complex number to the given power. So it has a complex number, and there's an exponent. And so the reason why it says use a unit circle is, I'll show you. First, let's just flag what numbers we see here. We see 1/2 and the square root of 3 over 2i. Those are the two parts of that complex number. And if I go over here to the unit circle, I will see right there 1/2 square root of 3 over 2, meaning it's right 1/2, real number 1/2, imaginary number square root of 3 over 2. And that is at 60 degrees. Now here's the deal. When you raise something to an exponent, what you're doing is you're multiplying the value again and again, but then you're spinning it again and again. Well, everything on the unit circle has a value of 1. That's what makes it the unit circle. It's 1 away from 0. So when you raise 1 to any power, the value remains 1. The only thing it changes is where it is. It starts to spin around. So all I have to do here, oops, sorry, I'm clicking the wrong thing. All I'm going to have to do here is look at the degree that I'm at right now, which we just saw this was at 60 degrees. So let me just capture that again. See how it says 60 degrees right there? Okay. Actually, I'm pointing. 60 degrees, that's the 1/2 square root of 3 over 2. 60 degrees. And then I'm going to raise that to the 5th power, which means I'm going to spin 60 degrees 5 times. And all I have to do is multiply this by 5 to figure out where you're going to land. 5 times 60 is 300. I go back here, look at 300. Here's 300 degrees. And what's that? 1/2 and negative square root of 3 over 2. So then when I go here to write my answer, I'm just going to write 1/2 negative square root of 3 over 2 and then an I. Because I got to write it in complex number form. I realize that's probably not the easiest to read. And so there's no comma. It's written in complex number form, a plus bi. Okay? And so that's the process. Sometimes you have to spin around more than 360 degrees, but I mean, that's the process that you're doing. We've done something similar to this before, and you're just taking where is it, and you're spinning it. Help each other with this one, and go ahead and pause and finish those other 3. And then I'm going to give you instructions on how to do the next section. So the next section is the opposite. It's where it tells you the result, some number on the unit circle, and it asks you to find the root. What did you multiply by itself that many times to get there? So I'm going to go ahead and walk you through this. Let's take, which one do I want to do? Let's take this one as an example. This is the 6th root of -1. We'll just start at the beginning. So I need to find -1 on the unit circle. So I'm going to go over to the unit circle. Where is -1? Well, -1 is here because this is that's the real part. So -1 plus 0i. That's what that would be in complex form. -1 plus 0i. Well, that's what -1 is, just 1 to the left. So there I am. What's the degrees? 180 degrees. Well, this time I'm asking, what did I multiply by itself? How many times? 6 times. What did I multiply by itself? 6 times. So I take that 180 degrees. Instead of multiplying it by 6, I divide it by 6. Okay, well, let me get that. And when I do that, I get 30 degrees. And so now I'm trying to find the answer that's at 30 degrees. So I go back over here, and right here is 30 degrees. Square root of 3 over 2 and 1/2. So when I go to write my answer, I'm going to write square root of 3 over 2 and 1/2. And then to finish it out, to write it in complex number form, okay, that's positive, so I'm going to add that. And this one is my I direction, my up-down direction. And so that's the answer. That's how you do those. But there is here an exceeding challenge. Because the reality is, if I'm asking for the 6th root of a number, there are actually 6 answers in the complex number system. There are 6 different values that all, when multiplied by themselves 6 times, would result in -1. And at first you might think, well, how are you going to find all of those other ones? Well, it's actually kind of standard. So you take your first answer, okay, and then you take 360 degrees, always 360 degrees, and you divide it by your root here, so 6, okay? So 360 divided by 6 is 60 degrees. So this right here is 60 degrees. And when I go 30 degrees plus 60 degrees, I get 90 degrees. And when I go look at 90 degrees on my unit circle, 90 degrees is 0, 1, which means 0 real, 1 imaginary. So it's just I, it's 1 up. Okay. So that is an additional answer, I. But then I continue to go every 60 degrees because this is a fraction of a circle that if you repeated, you'd always land at 360 degrees. Because if you did 60 degrees 6 times, you'd always land at the same spot. And so I just go another 60 degrees from that spot. So if I go another 60 degrees, I'm at 150. So I started at 30, I went 60 degrees, I go another 60 degrees, here I am, here's another answer. Every 60 degrees will be another answer. So here's minus root 3 over 2 plus 1/2 I. So minus root 3 over 2 plus 1/2 I. Okay, I've written that down here kind of sloppily. So here I got 3 answers so far. And that's what the exceeding challenge is to find all of them, all of those answers. And your sort of hint here with this one is don't consider 1 as a 0 degree, but consider it as a 360 degree, and then you'll find your 12 answers. Okay, go ahead and pause the video, do the other 3 there, do the exceeding challenges, and then we can get back to the last thing on the bottom. Okay, assuming you've done the first 2 sections, we're ready for the last section. This one says use the Pythagorean theorem to calculate the absolute value. And it says do not use rounded answers, which means if I have a square root that doesn't come out to be a nice whole number, you just stop. I'm going to do the first 2 as examples, but before I do, just a quick thing on the back here. Okay. We'll get back to this page later, but if I look at this coordinate, this complex number, a plus bi, this distance is a and this distance is b. And so if I want to find the distance from 0, well, that's a squared plus b squared equals that distance squared. Okay? I'm using d for distance. Well, to solve for distance, I take the square root. Okay? And what this means is that the absolute value of any complex number, there's the formula. In other words, let me write it down here, and you can write it down here. The absolute value of a plus bi is the square root of a squared plus b squared. Notice there's no I in this formula. You will never put I inside of this distance because I is a direction. When we're doing distance, we don't care about direction. We just care about how far you went. Okay? All right, so how's that work? So let's go up here. All I'm going to do is I'm going to take the 2 numbers. I'm going to ignore all of the directional things, negatives, I's, all that sort of stuff. The 2 numbers here are 3 and 4. So I'm going to square 3. I'm going to square 4 and add them and take the square root. This turns out to be 9 plus 16 is 25. And the square root of 25 is 5. There is my answer. Okay, on this one here, the 2 numbers are 2 and 3. I'm going to ignore any negatives or i's or anything. And that's 2 squared plus 3 squared, which is 4 plus 9, which is the square root of 13. And since the square root of 13 does not come out evenly to a whole number, I'm done. I don't want you to write a decimal approximation. Okay? All right, that's it. That's all the extra for today. Everything else is, I just want you to make sure you have finished up all that is previous. It's just these 10 problems that I've asked you to do. If you've followed along with me, you have done 4 of the 14, and so there's 10 left to go. And I should be back tomorrow.